Hi, myself Kunal, and we are doing knowledge building on supervised learning. In last class, we have discussed about supervised learning on continuous variable. We discussed about regression to solve that problem. Please see my previous video for this lecture. In this class, we're going to learn about classification supervised learning problem, where we need to classify a given set and build a machine learning model to solve this problem. We will be learning the use of support vector machine in this class for this classification problem on categorical variables. So अगर आपके variables categorical हैं तो you need a classification learning algorithm, and if your variables are continuous you need regression or some continuous variable based supervised learning algorithms. So classification problem can be thought of as जैसे like राम पढ़ता है and श्याम खेलता है. So these are two categories of students. Why we need machine learning model for this? So let's say let's consider the example of Amazon. Amazon has this data कि राम पढ़ता है and श्याम खेलता है. So Ram will be buying study material or books from Amazon, and Shyam will be buying playing equipments or game or CDs from Amazon. So now Amazon will show, based on this categorical segregation, Amazon will show the study materials to Ram and or say books to the Ram, and then the playing equipments to Shyam. Okay guys, so this is the use of this classification problem. We will be learning support vector machine in this class to solve this classification problem. Okay, so first of all, what is a vector? In mathematics, vector is an object which has both magnitude and direction. So even a single line, y1 is equal to mx1 plus c. This line has this magnitude m and a direction. So this line is a vector for mathematics term. Now this vector can be in 2 dimension, can be in 3 dimension plane, where it will be having x, y and z axis, or it can be in n dimension, y is equal to m1 x1 plus m2 x2 plus m3 x3. Okay, so we're gonna use this vector to segregate the categorical variables. Okay, I think how we can do this, and let's take simple cases first. So मैंने already draw किया हुआ है. So let's say हमारे पास ये दो sets हैं. Okay, one is the red one is the blue one, and we need to divide these two sets in different categories. So this is cat 1, category 1, and this is category 2. Okay, so now we can have multiple lines, multiple vectors to separate this plane, right? Let's say okay, or this line. So we can have many vectors. Now how to optimize these vectors? Let's say हमारे पास ये जो था ये test set था, इसके basis पे we have drawn this line. Okay, let me draw. Just ये हमने एक line draw करी. तो ये हमारा टेस्ट केस था, इसके बेसिस पे हमने लाइन ड्रॉ करी. नाउ ये हमारा ट्रेनिंग सेट था, इसके बेसिस पे हमने लाइन ड्रॉ करी. अब हमारे पास एक टेस्ट वेरिएबल है which lie on this side, which basically should go to this data. Okay, this side. So ये जो सो यू अंडरस्टैंडिंग कि हमें क्यों जरूरत है करेक्ट लाइन आइडेंटिफाई करने की. मैं इसको और क्लियर करता हूँ इस इमेज को. लेट्स से let's take to this. Okay, let's say मैंने ये लाइन ड्रॉ करी. There can be any line. This line is correct for this training set. This line divides the set into two categories, this one and this one. Okay, but let's say अब मेरे पास जो टेस्ट सेट है उसमें एक जो वेरिएबल है वो यहाँ है. एक जो मेरा जो डेटा है जो कैटेगरी 1 से बिलोंग करना चाहिए वो यहाँ पे लाई करता है. Let's so now my this line is wrong. Okay, but if I draw this another line, so this divides this data set correctly for both training and testing data set. Now, just supervise why we need machine learning algorithms here. This is to choose from different lines that which is the best fit line to segregate this data into two parts. Okay, how this support vector machine work in this case? They consider the margin. So this is the distance between these two lines. This is their margin with every variable. So how it works is they try to maximize the margin. एक लाइन जो हर वेरिएबल से मैक्सिमम डिस्टेंस पे सेट होगी, that will be the best fit line in this case. So again, this is the margin. So if you consider the margin of these two lines, this line will be at maximum distance from all these variables. So this will be our best fit line in this case. Okay, but अब now let's consider another case. ये वो केस था जिसमें एक्चुअली में कोई लाइन किसी डेटा को दो सेट्स में डिवाइड कर सकती है. Now let's consider another case. Okay, so this is the case where there cannot exist an actual line which can divide this data into two sets because this data is actually intermixed data. So now how the mathematical equation work in this case is we are trying to maximize the margin, or we are trying to minimize 1 divided by margin, right? Maximization of this is equal to minimization of this 1 divided by margin. Okay, and for this case let us consider a loss factor here. So what we're gonna do is minimize 1 by margin plus sigma summation of penalty for all the variables. So for any line, what is the margin? Margin is the difference of each variable from a given line. So let's say if we consider this black line, मैं आपको यहाँ एक्सप्लेन करता हूँ. एक जो लाइन है इसके लिए मार्जिन क्या होगा, लेट्स इसके चारों तरफ ये दो वेरिएबल्स हैं, तो ऐसे वेरिएबल्स जो इस लाइन की एक ही तरफ है उनकी डिस्टेंस, इसका डिस्टेंस this distance will be margin, right? हम जानते हैं ये चीज. So what we gonna do, we gonna try to minimize 1 divided by this. Now what is penalty? Penalty है जो रेड वेरिएबल इस लाइन की दूसरी साइड में उसकी डिस्टेंस, या एक ब्लू वेरिएबल जो लाइन के इस तरफ है, ये जो वेरिएबल है एंड ये जो वेरिएबल है, इनकी डिस्टेंस इस लाइन से, बेसिकली द नेगेटिव ऑफ मार्जिन, दिस डिस्टेंस is your penalty. So 1 by margin plus penalty, इसकी जो मिनिमम वैल्यू जिस लाइन से आएगी, that will be our the best fit line. Okay, this value is called hinge loss. So we are trying to minimize this value. This value is actually 0 if there are no overlaps. And it has a non-zero value if overlaps. Clear है ये यहाँ तक? अगर आपको कोई भी डाउट हो तो गाइस प्लीज मेंशन इन कमेंट. अगर इनमें ओवरलैप नहीं है, so penalty की वैल्यू will always be 0. We're gonna compute 1 by minimize 1 by margin and we'll get the best fit line. अगर ओवरलैप है किसी लाइन से, so then there will be a penalty and we need to minimize this whole thing, minimum of 1 by margin and summation of penalty, okay, to get the best fit line. But again, ये वो केसेस हैं जिनमें डेटा को डिवाइड करना पॉसिबल था. ओके, नाउ देयर कैन बी केसेस वे डेटा को डिवाइड करना पॉसिबल ही नहीं है. ओके, इसके लिए बहुत डायमेंशंस में जाने की जरूरत नहीं है. लेट अस कंसीडर अ सिंगल केस, इवन वन डायमेंशन केस, where we can consider where we cannot segregate the data simply looking at it. Okay. So far we have learned this was support vector machine, soft margin summation. We are taking the margin, we are doing summation of it, and we are minimizing 1 by margin and getting the line. So this is called soft margin support vector machine. This technique is called soft margin support vector machine. Okay, अब हम और complex problem देखते हैं. So let us consider this case. Okay, so here this is a one dimension array. This point is x equal to 0. अब हमारे पास दो तरह का डेटा है, एक 0 and 1 is x. ओके, तो आप देख रहे हैं कि शुरू में यहाँ पे x है, then 0 and then again x. So कोई भी ऐसी लाइन एग्जिस्ट नहीं करती जो इस डेटा को दो पार्ट में डिवाइड करती. ओके, if I draw a line here, then there is a whole bunch of x's which are here and which will be categorized as either 0 or all the zeros will be categorized as x and these all x will be categorized as 0. So ऐसा कोई प्लेन ही एग्जिस्ट नहीं करता जो इस डेटा को दो पार्ट्स में डिवाइड कर सके, राइट? But now mathematically, let's say if we change the dimension, let's say we consider another variable y. which is all these variables have only x dimension, right? So y is equal to xi minus 0. All these variables are having xi, right? Xi, some, let's say x1, this is at x2 distance, this is at x3 distance, this is at minus x4 distance or minus x5 distance. Okay, so let us introduce one more variable y, which is xi minus 0 origin. So if we consider this and we plot a graph here, now this is this thing what we are doing here, this is called SVM kernel. Okay, which converts actually us, which is actually increasing the dimension of this problem. This was a single dimension problem and now we are dealing it in 2 dimension. Okay, so there are some variables x which are at negative distance, right? These are at negative distance. These are at negative distance, and then these are at positive distances. Okay, and then there are O's, which are at positive distance. Okay. Now in this case, there is a possibility to draw a plane like this. But there can be multiple planes which can exist that can segregate this data. This is called SVM kernel. Let us take one more case of how SVM kernel works. Now let's say I have a 2-dimension data. Okay, so one is this red one are these blue ones. So as you can see that inside these black circles all are red ones, and outside this black circle everything is blue one, but still there is no plane that can segregate this data, right? So again, in this case also, SVM kernel will going to introduce another variable or another dimension here. Let's say z is equal to distance from center. Okay, or let's say r, radius of circle. So if we going to draw this data in 3 dimension, then how it gonna look like is this. Okay, so this is the center line, or this is the center line. This is the data that is increasing the distance from center. So you can see now there can be a plane exist which can divide this data into 2 categories. So here kernel SVM is actually introducing one more dimension to solve the problem. This is a classical example where जैसा कि हम हमेशा से पढ़ते थे कि with more dimensions complexity get increased. So here with having the more dimensions, here we are having 3 dimensions, that the complexity is actually getting reduced. We can clearly apply SVM technique to divide this data into 2 categories. Okay, so guys, this was SVM. Thank you for watching the video. please, if you are liking this video, please subscribe the channel and like the video. Please ask your doubts in comment. And in next class, we're gonna learn practical SVM using Python. Thank you.